Hello, Bhishma, can you see my screen?
Yes, Karthik, I can.
Yeah, thank
Yes.
you.
Karthik, I think we can start. Karthik, you are in mute, Karthik.
Hey, all this while I was on mute, you didn't hear me?
Yeah.
Oh my God, I'm really sorry. Okay, let me start all over again. Good afternoon, everybody. Thank you so much for joining. Today, we will be focusing our energy on callback function. All right, so about the speaker, I'm Karthik. I have around 18 plus of years of experience working in radio frequency electronics and automotive electronics. And ANSET as an organization, we've been in the market from 2007, working exclusively in the automotive industry. We have worked with clients in the semiconductor industry. We have worked with clients in the tier one OEMs, etc. But all of them focused on the automotive industry. That's a quick background about me and the organization. Thank you once again for joining this webinar. Unfortunately, we couldn't host the webinar last week because of personal issues. All right. So today we'll focus our energy on the communication stack. Okay. So we will spend a bit of time on telling what are the features of the communication stack. A quick introduction. You can refer our previous webinars for more details. We will also talk about how do we configure the callback function. What is the need for a callback function? How do we configure a callback function in the communication stack? 2. 3, we will talk about what are the challenges that are faced in implementing the communication stack from a developer's perspective. Okay, so even though the prototype, when you configure it in the stack, what happens? How does the code get generated? And then how do you implement the communication stack? So these are certain challenges that we will be facing as a developer. And I'm trying to address this challenge in this webinar. Just a word of caution at the beginning of the webinar. This is one of the methodologies that we recommend, and this is also some of the recommendations that we as an engineering team have learned with the OEMs and tier 1 companies. But this is definitely not a hard proof mechanism. We would really recommend, if you have better mechanisms of the communication stack, or if you have any challenges about the communication stack, I strongly recommend you write to us, and we can actually set up a discussion on how to kind of implement it better. So I'm open for that. But whatever we are saying is from the experience that we have as a team implementing the callback function in the communication stack. Okay. Typically, this is the whole communication stack in a nutshell. We will limit our focus on the CAN stack. So that is why on the left-hand side, you have a communication module, you have a PDU router, you have a CAN TP if you have a CAN message which is to be greater than 8 bytes. Then you probably use the CAN TP. Otherwise, you don't need a CAN TP message. CAN TP module, and you have a CAN IF module, and you have a CAN driver. Okay. So, what is our predominant role? Is we are trying to implement a callback function. Okay. Let us say, for example, I give you a use case. We will implement this particular use case. Maybe. Let us say, for example, you are expecting a CAN signal every 100 or 1000 millisecond. Every 1 second, you are expecting a CAN signal. You are not receiving the CAN signal. Okay, so what do? Then I have to write a callback function which will go and handle this mechanism. This is exactly what our use case is all about. Okay, so we will be configuring this in the communication module. Okay, where we are looking in the receiver side, you are looking for a particular signal. And if you don't receive the signal in a particular, it may not be a timeout notification, it could be anything, but I'm taking the example of a timeout notification. But the implementation mechanisms will still remain the same, irrespective of what kind of errors or how you want to call the callback function. So we have to implement the callback function in the COM module. Okay, so that's the whole idea. I will now switch to my this is my EB Resource tool. Okay, this is my EB Resource tool. And I'm actually going to configure this, but like I said, the use case is very straightforward. I do not receive a CAN signal. I am expected to receive a CAN signal every 1 second, but I'm not receiving it. What should I do? Okay, the course of action. Okay, that is written in the application. What should be the course of action? The course of action could be anything. Like say, for example, if you don't receive a CAN signal in that particular signal in that particular testing environment, then probably you write a callback function which implements, say, I will use the older CAN value. Okay. So I will use the last appeared value. Like that, you can write whatever in the application. But how do you take it to the application? How do you take the trigger to the application? Or how do you trigger the application runnable? That's the whole point of discussion. Okay. So now the first step would be to kind of go to your COM module. Okay. In your PSW stack, you have a COM module. I would probably go ahead and search for the signal. In the outline, okay, see, this is the in the outline, this is the COM configuration. I have my COM signals. I just have 2 signals. Okay, so I'm just taking this particular signal as a reference. Okay, and I will go to my okay, here it is. Yeah, so I have, like, say, I'm giving a timeout value. Okay, so the timeout value is like, say, 1000 second, or sorry, 1000 milliseconds. So I've given a timeout value, and I've also written, okay, if I don't get a signal in this time period, what I do? So I trigger a callback function, and the name of the callback function is time notification. This is something that as a user, you define the name of the callback function. Okay, so this is the first step. I'll probably use some notes. I'll use the notepad. Okay. The first step is to configure the callback function in the tool. All right. This is the first step that we have done. Okay. Now, once this is done, I would go to my project. I'll go to my project and probably generate a project. I've already configured the COM module. Okay, the rest of the COM module I've done. Just that I'm trying to implement a callback function. So this is the callback function. I will open my Eclipse Studio. And if you see in my LCFG file, okay, you see that the prototype of the callback function is actually given. Okay, so you have a prototype, and if you look at the function call, okay, so here you have. So this particular function will be called whenever you say that a timeout has been, like, say, expired. This particular function will be triggered. Okay, so this function is being triggered by the what is it called, COM module. Okay, so sometimes what happens is you will find this in your here you find it in the LCFG file, but many times what happens is it may not be in the LCFG file. It could be in, say, different .h files depending upon the tool. I am using a electrobit, so in the electrobit it is available here. But if you are using a different tool, you will find that the timeout notification will be generated in different .h files. And if you look at the properties here, if you go to and look at the properties, you will find the location in which this particular function prototype will be called. Okay, so this is the first step. So second step is you have identified, okay, there is a timeout notification, and this is the function. Where is my, yeah, this is the function prototype of that particular notification. Now the question is, okay, how do I trigger? Okay, now this is triggered by the COM module. Okay, now how do I write an application code which will define what has to be done in terms of, like, say, when this notification has to be called? Okay, one simple and straightforward mechanism is, okay, so you have your communication services. In this module, you have your callback function that is being generated, the callback function. You can go ahead and straight away write in the application layer, you can actually write the function definition. Okay, the function call is happening here, you can write the function definition. But what happens is, many a times it defeats our AutoSAR standard. Okay, so what happens is, if I write, if the function call happens in the COM module and in the function definition is written in the application layer, the problem is this particular function definition, okay, this particular function definition is triggered by the COM module. But as per AutoSAR standard, it is very clear that any runnable in the application layer has to be triggered by the runtime environment. Okay, it has to be triggered by the runtime environment. But if you go ahead and write the application layer directly here, that runnable directly here, and if your COM modules triggers this runnable, then it is not following AutoSAR standard. This is one of the biggest challenges that we as an development team will face. Okay, the second option is you could like, say, for example, write it in the RTE. Okay, one of the recommendations, okay, one of the recommendations is, like, say, use these callback functions at the far end of the code, and you write it in the RTE. So the function call will call the RTE, and the RTE will set an event, and that event in turn will call the application layer. But I think that's also definitely, I mean, at least the first case, there are many tier ones that go ahead and do that. But the second use case is strictly a no, because I would recommend, because whenever there is a change in that comes in the configuration in the RTE, the tool will overwrite the code whatever we have written. Okay, because the RTE has to be generated by the tool only. It is not to be written by the application developer until and unless the whole RTE itself is written by the application team without the use of a tool. So the second is also definitely a no. Okay, so we, in our experience, having worked with some of the OEMs and some of the architects, we have some of these recommendations, and I thought I will share these recommendations here. One recommendation is that when this application function is being when the timeout notification is being triggered, okay, the biggest disadvantage is this is generating a callback function, and this callback function is itself not part of AutoSer. Okay, so this callback function, this particular function is itself not part of AutoSer. Then what happens is it's not similar to this RTE com callback where it will call the RTE, it will call the RTE layer, okay, but it's a completely different callback function. So this callback function will be taken outside the AutoSer. Okay, it will go out of AutoSer. So how do we bring it back into AutoSer? So there are two methodologies that is recommended. One is once you take it out of AutoSer, the best way to bring it back to AutoSer is through the complex device driver. This is something that we have suggested. Okay, so through the complex device driver, you can actually like say bring it back into the AutoSer. That is one way of doing it. The second way of doing it is through the operating system. Okay, so that's the second way of doing it. But let me now just focus on how do we kind of write this callback function through the complex device driver. So that is something that we will try to do. Okay. Okay, so this is the particular timeout notification that is being generated. Okay, this is the timeout notification or the name of the function prototype that is being generated as a result of the signal not received in 1000 milliseconds. Now, what you will have a CDD file. Okay, you will have a CDD file. Okay, in this CDD file, I'm going to write the function definition of the complex device driver. Okay, this is the function definition of the complex device driver. So I will bring this into the complex device driver, and what I will do is I will like say this is the RCT timeout runnable. Okay, this is the application software component runnable that needs to be executed when the timeout expires. So when the timeout expires, what happens is this particular runnable has to be called. Okay. So I am just like say writing one function definition and I'm like say calling this runnable, but this will not trigger the runnable directly. Okay. So what we have to do is the first step in order to do this, okay, we will have to create an application ARXML file. Okay, I will say we will have to create an application ARXML file. That has a runnable named this guy. Okay. Now, the most important thing is this name of this runnable, and when we configure the BSW stack, okay, when we configure the BSW stack, this runnable name should be same. Okay, unfortunately, if you look at it, it is not the same. So it will not like say work. So we have to configure the runnable name to be similar to that of what it is to be configured in the application. So that is the first step that is to be done. Okay, so now what happens is this runnable, I'm sorry. Okay, so this, then you configure, then you have in the callback function in the BSW stack, you have already configured the name. Okay, so this will generate this function prototype. Okay, it will generate the function prototype. I'm going to rename this. I will in fact rename this. Oh, sorry. Okay, so this is exactly the runnable name that has to be configured in your application, and it will be the same runnable name that you will be giving in your callback function. Also, when your COM module finds that the timeout has expired, it will directly call this runnable. It will directly call the runnable, right? So in the application layer, what we can do is once you configure this runnable, you can create an access point. I will probably call this guy as timeout notification, the same name give it. Okay. The access point, what I will do is I will create a server port. Okay. And this particular runnable. This particular runnable. Okay, so what happens is this particular runnable, we will like say in the application. Okay, in the application, you will configure this particular runnable as a server. You will configure this as a server. Okay, and because you have configured this as a server, the whole idea is you will need one client port. Okay, so that client port will be like say, sorry, I will call it like say RC. So you will need one client port. Okay, so the client port will be created in the CDD file. Okay, you can create the client port in the CDD file. Okay, so what happens is when you have a timeout, the timeout will call this particular function, and this function in turn will invoke this client call, which in turn will call the server function, and you can write the definition of whatever you want to do in the application. Whatever you want to do, you could actually write it this way. So this way, what happens is you solve both the problems. One, because it has gone out of AutoSAR, you have taken it into complex device driver, and through the complex device driver, you have provisions in AutoSAR. You know that through the complex device driver, you can always call the application runnable. So this is something that is supported in AutoSAR. So we are still following the AutoSAR standard. So this is a very this is definitely acceptable as per AutoSAR definitions. Okay, so that is one way of how we address this problem through the complex device driver. The second way of also addressing this problem is also similar. Okay, it is again through the complex device driver. But sometimes what happens is you would like this particular runnable to be configured as a non-blocking function. Okay, you would like this runnable to be configured as a non-blocking function, or what we call it as a runnable category 2. If that is the case, then sometimes what we will have to do is some architects will definitely enforce that it has to be called, some particular runnables have to be called through the operating system. Okay, it has to be called through the operating system. So that again can be handled. What we could do is we could actually do the same procedure with a different, with a little bit of difference. The first step, of course, will be to configure the callback function. Okay, now we will try to write it through the OS. We'll call it trigger the runnable through the OS. So when we want to do it through the first thing is you will have to configure it in the tool. This is something that we have to do. And then what happens is in the application software component, create a runnable. I'll call this runnable. Here you don't have to worry whether it is in the same name, no problem. Okay. So you create one runnable, and this runnable will be triggered whenever there's a timeout happens. Okay, and you can write logic inside this runnable. That's fine. So this you create a runnable, and when we set the trigger for this, I mean, we will have to create an external trigger. So whenever we are configuring the ARXML file in the application layer, one thing that we will have to do is for this particular runnable, you will have to choose your access points, and you will probably say some external trigger to be set for this particular runnable. Okay, you need to provide some triggering point. Access points. You need to create an external trigger access point. Right. So now what happens is you will have an access point that is being created, and through the access, through you will have an external trigger that is being created, and through the access point you can actually reach the runnable. Okay, so this is done. Now what we will do is you will map this runnable to the OS task. You will map this runnable to the OS task. Okay, and let's say, for example, I give it a name. I will call it like say application task 1. This is the name of the OS task. You will like say do it. Okay, and you'll probably give it like say priorities. You will give all the other configurations that needs to be done in the OS task. This is all done. Once this is done, the next step will be okay. So what happens is when the flow will actually go like this, okay, so your RTE start will trigger RTE, okay, and this particular application task one, we will continuously keep monitoring for if the event is set, okay. An event could be anything. Okay, let us say, for example, in our case, it is our trigger. I'm sorry, the external trigger. Okay, so we will have to like say keep it as an external trigger, and that will be our event. So once this particular event is set, if the event is set, then the runnable will be called. Okay, this is the runnable. Okay, the RCT timeout notification runnable. So you will call this particular runnable. So this is how your OS, I mean the RTE and the OS will work together. So now this happened. So the problem is you have configured the trigger, and whenever this particular event is set, then this particular runnable will be triggered. So this is one half of the story. Now the second half of the story, idea is, I'm sorry, there is some background noise. I think someone has put their microphone on mute. Thank you. Okay, the second half of the story is, okay, now that you have like say set a trigger for the runnable, this is like say done. How do you trigger this event? How do we trigger this event? So in order to do that, we will have to write this function definition. Okay, now like I already mentioned, this is the function prototype, which I copied it from the LCFG file, and I've like say kept it in my cdd.c file. Okay, again, it has to be done through the CDD, but I'm keeping it in my cdd.c file. And in my cdd.c file, what I will do is I will first include the os.h file. Okay, that will be something that we need to do. And what I will do is I will set the event here. Okay, you know, this is the particular function definition of this particular to set the event. Okay, this is the function prototype. You will call the application task and the name of the event. Okay. So what I will go to do is I will actually generate my rt.c file. Okay, I will generate my rt.c file, and what I will try to do is I'll write this set event, and I'll probably call what was the name of this guy? Okay, application task 1. I will call this event name. Okay, it could be something like rt underscore event underscore some external trigger. This is something that you can pick it up from your RTE, and you can like say that exact name that you can take it, and you can like say keep the name of the masked event here. All right. So once you place both these fellows, what happens is, and you will find that whenever an notification is called, the notification, whenever a timeout happens, the notification will be called. This notification function will be defined, and in the definition of the notification function, we have set the event. Okay, and because this event is set, what your rte.c file will do is, in your rte.c file, you know that this particular OS task, okay, this particular OS task is continuously searching for this event. And now that the event is set, what it will do is it will call this particular function, and inside that function, you can write the logic. This is a very interesting methodology of doing it, okay, where we involve the application OS task also, and the OS task, I'm sorry, we include the OS also, and this can be used for, like, say, for triggering runnables, especially if you want to, like, say, use non-blocking functions and all those things, you could definitely do this. But on the other hand, the second method approach is, like, say, you take it to the CDD again. But what you could do is you can, like, say, create a callback function. Step one remains the same. And in the application ARXML file, you can create one timeout notification. Similar, this runnable you can create. And what you could do is you can use a client server port from the CDD. You can call the application through a client server port. Okay. So because it is called as a server call, there is no need for mapping it to an OS task. Okay, in the first method, there is no need for it to be mapped to an OS task, because the CDD is directly calling the server runnable, and then it will trigger it. Okay. So these are the two approaches that we in our team have been following in order to write callback functions. This is a huge topic of debate, because many times what happens is this function, once you configure it and this function is generated prototype, people actually write the definition directly in the application layer itself. So what happens is, whenever the callback happens, communication module is called, it will directly call the application runnable and the application will execute it. But the biggest challenge is many technical architects will not agree to it. Primary reason, because it will break the rule of AutoSAR, and the primary idea of it has to be triggered by the RTE is, like, say, overlooked and things like that. So this is something that we need to take care of. Primary reason, like I said, this callback function is not part of the AutoSAR standard, and it is actually taken out of AutoSAR standard. So how do AutoSAR? That is the biggest point of discussion, and that's why we use a complex device driver to bring it back into AutoSAR. Okay, so this is something that we have done. Function call happens in the communication module. It will call the complex device driver. You could, like, say, write implement the callback function here and call the server application runnable. Two methods you could follow to call the application runnable. One is you could go through the OS, or the second one is you can avoid the OS and directly call it as a server runnable. Both these options are possible. And I believe that both these options do not break the rule of AutoSAR, and it should be implemented. I think these are some of the best choices that we have implemented as a team. But I really look forward if you have some other suggestions on how to improve it, or like other methodologies to implement callback functions. We will be more than happy to kind of discuss and take that forward. All right, so that's a quick introduction on how do we implement a callback function on. I demonstrated it on the Electrobit tool, but like I mentioned, every other tool also will have the same methodology of implementation. Just that the function prototype could be generated in different .h files depending on the tool. And yeah, that's it pretty much from our side. If you have any interesting questions, I will probably take that, and I hope that I could answer some of your questions. I hear some bad questions. Hearing echo voice. Okay. Any questions? If we have. Bhishma, am I audible?
Thanks. Yes, Karthik, you are.
Yeah, okay. I think there are no questions.
Yes, Karthik, there is. Is there any questions from the participants? In that case, Karthik, shall we wind up?
Yeah. Thank you all. Thank you again for joining us. It's a wonderful hosting you all. Thank you so much for joining once again. And I wish you a very happy month and a very happy Independence Day. I will meet you on the first Thursday of next month with yet another interesting webinar on AutoSAR. Thank you so much. You all have a nice month. Take care.